As developers, we write code, we hit save, and boom, a web page just appears on the screen. It feels like magic, right? Instantaneous. But what's really happening on that journey from typing a URL to seeing the final pixels? Understanding this process isn't just trivia. It's absolutely fundamental if you want to build fast, efficient web applications. So today, we're going to map out that exact path, step by step. Every single time you hit enter, you're kicking off this incredible chain reaction of events that literally spans the globe in milliseconds. It's this precise dance of requests and responses involving real physical hardware and layers upon layers of rules and protocols. So let's pop the hood and see exactly how this whole thing works. And while it might seem super complex, at its heart, it's really not magic. It's just a roadmap. A series of logical, predictable steps that connect your computer to a server somewhere out there and brings the data all the way back. Let's trace this journey together and put every single piece of the puzzle in its place. Okay, so let's dive in by busting a massive myth right from the start. We hear the term the cloud all the time, and it makes you think your data is just, floating around in some digital mist up in the sky. But the reality is so much more concrete. Let's place our first pin on the roadmap. The physical, tangible foundation of the web. This quote from Aaron Titus just cuts right to the heart of it. Before a single packet of data can be sent, before any request can be made, we have to get our heads around the physical reality of it all. The internet is built on real, tangible stuff. Let's see what that actually looks like. So that wire is actually a global network of over 1 million kilometers of physical cables. A lot of these are fiber optic lines running deep under the ocean floor, connecting continents. And these cables all lead to data centers, which are really just big buildings full of powerful computers we call servers. So when you host your website, you're literally just renting a little bit of space on one of those servers. And your router at home? That's just your personal on-ramp to this massive physical network of networks. Okay, so your computer is plugged into this giant physical web. But with billions of devices out there, how in the world does it find the one specific server that's holding the website you actually want? Well, this brings us to a really brilliant solution that works like a massive global phone book. And that phone book is called the Domain Name System, or DNS. See, we humans remember friendly names like developerroadmaps.com. But computers, they need a specific numerical address, an IP address, to find anything. DNS is that essential translator that bridges our world of words with the computer's world of numbers. This is an absolutely critical checkpoint on our roadmap, so let's break down how it works. The very first time you visit a site, this lookup is a whole multi-step adventure. Your browser's request first goes to something called a recursive resolver. Think of it as a helpful librarian. This librarian doesn't have the answer, so it asks the main index, a root server. The root server points it to the right aisle, say the .com server. Then the librarian goes there, and that server points to the exact shelf, the authoritative server that holds the final IP address. Only then does that IP address make the long trip all the way back to your browser. Yeah, it's a lot of back and forth. Now, that 8-step journey we just saw would be way too slow to do every single time, and that's where the magic of caching comes in. The system is smart, it cleverly stores the answer. So the next time you visit, the process is way simpler. It's just a quick 2-step lookup that feels almost instant because the answer is already saved locally. The performance difference, as you can see, is just massive. It's night and day. Okay, so we've found the server's address. We have the IP. Now what? Well, now the browser actually needs to talk to the server to ask for the website's files. And to do that, they both need to be speaking the same language. And that official language of the web is HTTP, Hypertext Transfer Protocol. It's really just a set of rules for the conversation. Your browser sends a request saying, "Hey, can you please get me this web page?" And the server replies, "Sure thing, here are the files." This simple request and response handshake is what kicks off basically everything you do online. But this language has had to evolve a lot to keep up with the modern web. The old HTTP/1.1 suffered from something called head-of-line blocking. You can think of it like a traffic jam on a single-lane highway. If one file got stuck, everything behind it had to wait. Then HTTP/2 came along and fixed that by turning it into a multi-lane superhighway. And most recently, HTTP/3 was basically designed for the mobile world. It lets you switch from your Wi-Fi to cellular data without just dropping the connection, making the whole experience way smoother. So, the files have arrived. They've been delivered from the server to your browser. Now the browser's real work begins. It has to take all these raw files, the HTML, the CSS, the JavaScript, and turn them into the visual, interactive page you actually see. This methodical process is called the critical rendering path. And this process follows a very precise order. First, the browser reads the HTML to build a map of the content, which we call the DOM. Next, it reads the CSS to build a map of the styles, the CSSOM. It then merges those two maps into a render tree, a final plan of only what's actually going to be visible on the page. From there, it calculates the exact size and position of every single element in the layout step. Finally, it paints the pixels and composites all the different layers together right there in your screen. But there's one more piece to this puzzle: JavaScript. And this is a huge checkpoint for performance. By default, when the browser is building the page and it comes across a standard JavaScript file, it slams on the brakes. The entire rendering process just stops dead in its tracks. It has to download and execute that script before it can do anything else, often leaving your user just staring at a blank white page. This is exactly why understanding how to load your scripts is such a critical skill on your developer journey. You can see here that by adding an async or defer attribute to your script tag, you completely change the browser's behavior. Both allow the script to download in the background without stopping the page from being built. But defer, which you can see in that last column, is often the best choice. It politely waits to run the script until after the page is fully parsed, guaranteeing it won't block that crucial first paint for your user. So we've traced the entire journey, all the way from a physical wire under the ocean to the final pixels on a screen. Now, let's bring it all back to your roadmap as a developer. How does knowing all of this actually help you build better, faster applications? Here are the key takeaways, your optimization checklist. First, always defer non-critical JavaScript. Second, keep your CSS lean and fast, because slow CSS can block rendering too. Third, write clean semantic HTML. Fewer DOM nodes means a faster layout step. Fourth, always set the dimensions for your images in your HTML or CSS to prevent the page from jumping around as they load. And finally, choose the right hosting for what you need right now. You can always scale up later as your project grows. You see, every single choice we make, how we structure our HTML, how we load our CSS, how we execute our JavaScript, it all has a direct impact on this incredibly intricate process. By understanding the path, you now have the power to build better, faster experiences for everyone who uses your work. This is Developer Roadmaps. Map your path, build your career.